I'd like to welcome you, class, to your first lesson of the year. Today what we're going to be discussing is rounding numbers. This is 1.A in your books. This is the approximation and error, the first chapter in your books, and the first section. Now, you guys have your books, which is Applications and Interpretations, SL2. Yours are online, so I'm just going to turn to page 16 to 20. And then what we're going to do is you're going to follow along in the book as I explain stuff up here. You're going to try the examples, and then I'm going to go over how to solve the examples. When you're doing the examples, obviously you're going to pause me and then try them on your own, okay? So let's see how this works. This is the first lesson. So here we go. And just full disclosure, this is the first time I'm actually giving this lesson. So if there are mistakes in it, I'll give you the errors that I make. Hopefully I catch them all, and then I'll put the right answers online. All right, so let us begin. Now there's an opening problem right here. I'm going to stand over here so you guys can see it. And what we'll do is we'll probably just discuss this in class as well. These three friends are looking at the Eureka Tower in Melbourne, Australia. They're trying to work out how tall that tower is, but they keep on arguing. Andres tries to carefully count the floors. He thinks there's 92. He estimates the average height of each floor to be about 3 meters. He estimates the height is 92 times 3, which is 276 meters. All right, that didn't seem like too bad of an idea. Then you got Bernadette. She tries to carefully count the floors too, but she's not sure of how many there are. So she thinks there's somewhere between 89 and 93. So she just guesses about 90. All right. She's sure each floor is more than 3 meters, but she thinks each one's less than 4 meters. Therefore, she goes, you know what, between 3 and 4, I'm going to say about 3.5 meters for each floor. Her estimate of the height is 90 times 3.5, which is 315 meters. Okay, a little different. She took a little different approach. Now, Carlos, he knows a lot about buildings. He wants to be an engineer. He's confident the height of each floor is about 3.3 meters. He's too lazy, though, to try to count the individual floors. So he counts them in lots by about 10, so just like chunks of 10. He's fairly sure 90 is the best guess, so he estimates the height to be 90 times 3.3 is 297 meters. So what we're going to discuss is, as a class, but I want you guys to think about this if you're reading, watching my video. Who do you think has the best method? Andres, Bernadette, or Carlos? It's one. Who was the wisest about the way they rounded the numbers? So who do you think rounded the numbers the best? And then C, the actual tower is 297.3 meters tall. So whose method is the most accurate? That's an easy one to figure out. And what percentage error do you think Andres' estimate had? All right, Andres. You can find the percentage error for all of them, and then we'll discuss that in class when we get into class. Okay, so these are just things I want you to think about before we get to class, so you're not just sitting there trying to brainstorm in class. All right? That's the opening problem. Now let me go into the actual lesson. There are many occasions when it's sensible to give a blank answer. So here's how this is going to work. Being that you guys are home and I'm here, I'm going to point to the camera, and you're going to yell your answer wherever you are. Okay? Unless you're in a library, don't yell too much. Just think to yourself. Just yell it out. Try to wake yourselves up a little bit. These classes are early. All right, so the answer is an approximate answer. Approximate is not exact. All right, so an example, the distance between the Earth and the Sun. Okay, why would we want to round that? The distance is what? 146,152,000 kilometers away. It's continually changing, okay? So it's between those two numbers. Because what happens is the Earth rotates the Sun. It doesn't rotate in a circular motion. It rotates it in an elliptical motion. So we would just estimate with an approximation system. Symbol. Do you know what that symbol is? You should know from geometry. Kind of looks like an equal symbol. It's like an equal symbol if you squiggled both lines. So that means it's approximately. It's not an exact answer, but it's approximate. Also, sometimes it's used an equal sign with the dot on top and bottom. So both of these mean approximation. I really don't like this one. I don't use it too much. This one is the one that we're going to be focused on. All right? Good? All right. It's not the congruent symbol. Congruent symbol is an equal sign with a squiggle on top. This is just two squiggles. So, rules for rounding off. So what we're going to do is we're going to round off some things. This is all stuff you should know how to do, but I'll describe it to you anyway. The digit after 1 being rounded off, is what we round down. So when do you round down? If that digit is less than 5. Less than 5, you round down. If the digit after the 1, you're rounding off, is blank, we round up. Greater than 5 and also equal to 5. So an example for this one, is 0, 1, 2, 3, or 4. And this is 5 or more. Okay, 5 or more, round up. Okay, less than 5, round down. So 5 or more would be 5, 6, 7, 8, 9. Not 10 because 10 is a 2-digit number. You're just really rounding 1-digit numbers. So this is something I threw in as well. This was really in your book, but I think it's very important to know. These are your places. So if I discuss places, you should know what the places are on a figure. First place, and you can keep on going up. This is the thousands. Notice the D there. All right. The next one is the, yell it out, hundreds. Right. 5,500. Tens. Isn't IB easy? Yeah. The ones. All right. What's this one? Not the tens, but the tenths. See the TH there? Once you get into decimals, you throw THs in. You got the tenths, you got the hundredths. Very good. Because this 3 divided by 10 is 0.3 tenths. 4 divided by 100 is 4 hundredths. After hundredths, you got thousandths, and then obviously 10 thousandths, and you can keep on going. All right? Good. All right, so what you're going to do now is you're going to try example 1. You can look at the questions, you can look up here and write in your notebook, or you can just look at the questions and get them from the book. Obviously, I'm going to give you all the answers, so if you did copy all the answers down, you have all the notes, but then you're not learning, so it's more important that you try this. So, and another thing to do is when you're watching this video, all right, try the first problem, pause it, unpause it, see if you got it right. If you got it wrong, okay, know what you did wrong, and then try the second problem, fixing what you did wrong in the first problem. All right, it's almost like we're in class. This is really far away class. So, 436 to the nearest 10. So the first thing you have to do is you have to figure out what is my 10 place. My 10 place is 3, 430, that's my 10 place. So since I'm rounding to this place, the number I'm rounding up or down is the 3. So I have to figure out if it's going to be 430 or 440. So I'm going to use the 6 to do my rounding, the number immediately after. Now 6 happens to be greater than or equal to 5. And any number greater than or equal to 5, you round up. And since you rounded up, that means I'm rounding the 3 up. 1 more than 3 is 4. So your answer is 440. All right, that wasn't too bad, was it? Now try the next 3. All right, problem B. To the nearest 100. That's 700. All right, so what number are we rounding? We're going to see what the 1 is. Now the 1 is less than 5. Less than 5, you round down. So it stays at 700 is your answer. All right? Because your answer for this will either be 700 or 800. Got it? All right, I'm going to go over the next 2. Obviously, if you just want to do one, pause it, another one, pause it, that's fine. I'm just going to keep on going through the answers. And this lesson also does take a couple days in class, so feel free to, I'll tell you where it usually ends in our class. All right, so to the nearest 100. So we're going to round it to that place, so it's either going to be 1,000 or 1,100. This is either going to be a 0 or a 1. Okay, you never go less than the number. It's either that number or 1 more. We're going to use the 5. 5 is obviously greater than or equal to 5, so then we're going to round up. 1 more than 0 is 1, 1,000. Right? Boom. The nearest 1,000. 9. So our answer is going to be 19,000. Or 9 plus 1 is 0, so that means we have to add 1 to here. It would be 20,000. All right, so 6 greater than or equal to 5, right? Round up. 9 plus 1 is 0. Add 1 more. 19 plus 1 is 20. So 20,000. Right? This stuff is simple. You guys should know it around. It is great to go over it again, though, in case you don't remember. Why don't you guys try problem 1 and problem 2? Go. All right, good. See, you already did it. Pause me, unpause me. round off to the nearest 10th place. So we're only rounding to the 10th place, so we're going to use the ones place to round. So I'm just going to highlight the ones. There's the 1 place. 6 happens to be greater than or equal to 5. It's greater than 5. So your answer is 90. We're using the 1. 81. So the answer is going to be 80 or 90. 1 is less than 5. Your answer is 80. We're going to use the 5. So this answer is going to be 80 or 90. 5 is greater than or equal to 5. Round up. So our answer is 90. Even though these numbers are different, when you round them to the 10th place, you get the same answer. Right? 128. Your 10th place is the 2nd place right here. So its answer is either going to be 120 or 130. 8 is greater than or equal to 5. It's greater than 5. So your answer is 130. Answer is going to be 160, 170. 2 is less than 5, so you're going to round down. Answer is 160. Good. All right, problem F. Answer is either going to be 100 or 110. 4 is less than 5. All right, so you're going to round down. Answer is 100. All right. G. Answer, you have 2 choices here. You have 630, 640. 5 is greater than or equal to 5, so your answer is 640. Right here, 1,822. All right, so, ready? 1,820, 1,830. The 2, less than 5, so you round down, 1,820. Right. 699. Your answer is going to be 690, or 69 plus 1 is 700. 7. So 9 is greater than or equal to 5. Obviously, your answer is 700. All right. So if it's a 9 and you round up, add 1 to the number immediately to the left of it. This one, we're going to use the 5. Your answer is either going to be 3,040 or 3,050. Because 5 is greater than or equal to 5, the answer is 3,050. And there you go. You already did problem 1. 1 problem down, a bunch to go. Ready for the next one? Round off to the nearest 100th place. So this answer is either going to be 200 or 300. We use the 10th place to round. So we're going to use that 1. That 1 is less than 5. So our answer is 200. 200 or 300. We're going to use the 6th to round. 6 is greater than or equal to 5. Your answer is 300. 3,700 or 3,800. We don't know which one it is yet. We're going to use that 5. 5 is greater than or equal to 0. You're going to round up. Your answer is 3,800. See that? Oh, so easy. Right here. Answer is going to be rounding up. 39 plus 1 is 40. So your answer is 4,000. You're going to use 4. 4 is less than 5. So 26,300. And there you go. If you got all those answers, it means you're on the right track to class. And see, told you IB wasn't that difficult. All right, now, I want you guys to try problem 3, round to the nearest 1,000, and then you're going to do problem 4. You're going to answer these words problems and round to the nearest unit they're asking, okay? Just because there's words in it doesn't make it more difficult. Got it? All right, let's go. First one, the thousands. So this is going to be 8,000 or 9,000. So we're going to use our 100th place to round, which is 3. 3 is less than 5, so our answer is 8,000. Use the 100th place. 5 is greater than or equal to 5. Round the 3 up to a 4. Your answer is 4,000. 2 is less than 5. You're going to drop all these, leave the 9 as it is, and your answer is 19,000. 6, greater than or equal to 5. Round that 19 up to a 20, 20,000. 8, greater than or equal to 5. So you're going to round the 4 up to 115,000. There you go. You're done. That was easy. All right, go. We're going to get out of the way here. All right, round off the accuracy given. So the first thing you want to know is the height of Mount Everest. So I'm going to get off the screen here just so you can see. Height of Mount Everest, you're rounding to the nearest 10 meters. Actually, I'm going to jump on this side. All right, so 10 meters is right here, so we're going to use the ones placed around. 8 is greater than or equal to 5, so we're going to round this 4 to a 5, and your answer is 8,850 meters. Don't forget to write your unit. The surface area of Lake Baikal in Russia is 31,722 kilometers, round to the nearest 1,000 kilometers. So we're going to round to this place. Our answer is going to be 31,000 or 32,000. We use the hundredth place to round. Since the 7 is greater than 5, we're going to round the 31 up to a 32, and you get 32,000 kilometers. Population of New Zealand in 2018 was 4,749,598. We're going to round that to the 1,000th place. We're going to use that 5. We're going to round that 5. We're going to use that to round the 9 up to a 0. Add 1 here, so that's 49 rounds to 50. 4,750,000. Attendance at an English football match, or as we guys know it as soccer, was 85,512. What do you think that was? Man U? Alright, so maybe Chelsea. Chelsea's better. Alright, nearest 100. 5 is the 100, so we're rounding the 10th place, which is 1. 1 is less than 5, 85,500. Area of Australia is 7,692,000 kilometers squared. Round to the nearest 100,000 kilometers. That's your 100,000, so it's 7,600,000 or 7,700,000. We're going to use the 10,000 place to round. The 9 is greater than 5. So this rounds 76 up to 77, so 7.7 million square kilometers. Average weight of an adult American elephant is 5,443 kilograms. That's a lot of weight. Round it to the nearest hundredth, so 5,400, 5,500, round the 10th place, which is 4, less than 5. This stays 5,400 kilograms. Distance between Paris and Sydney, 16,950 kilometers, round to the 100. There's your 100th place, so we use the 10th place. 5 is greater than or equal to 5. All right, so 16,900 becomes 17,000. 169 rounds up to 170. Average distance from Earth to the Moon. Why is it average distance? Because Earth goes around the Moon too, right? The distance there changes. 384,000. No, Moon goes around the Earth. Wow, that was really, really bad to say. Just forget I said that. I'm not gonna. I was gonna say like the Earth goes around the Sun, but my brain froze. 384,400 kilometers, round to 100,000. So it's either going to be 300,000 or 400,000. Since the 8 is greater than 5, you're going to have 400,000 kilometers. Finally, the population in 2018. So see, you got a new book. 2018 is where all these populations are of South America. Okay, the whole continent was 428,240,515. You know, that's not even as much, I think, as China or India have in their one countries. All right, so round to the nearest million. 428, 429. Well, the 2 is less than 5, so it's 428 million people. All right. In this class, how you doing? Doing good? All right, so now we're going to do some more talking. Rounding decimal numbers. So we already found that a total of 6,428 flights were taken by 825 people. What was the average number of flights per person? I just kind of reworded what the book had here. Made it sound nicer. So the exact answer was given to you. How do you find the exact answer about the average number of flights? All right, what you should have done was divide the number of flights by the number of people, which was 6,428 divided by 825. Type that in your calculator, which of course you're going to use, and you get 7.7915151552. I don't even want to say what that is using, what is that? 10,000, 10,000, 100,000, million. That's like billions. All right, so you don't want to write all that down, all right? So we'll estimate it. What would you estimate this to? Because this right here, that's not sensible. You don't want to write a big answer like that. Like no one says, how many flights average did you take? I took 7.79151515, blah, 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 blah. What would you think they would round that to? They would say the average person takes, that's 7.8 flights. You really wouldn't want to say 8 because that's round a little bit too much. But if you went 7.8, well, 7's 9. That's not too bad, 7.79. Well, 9, that's really close to here, right? So that's 7.8. All right, usually you have to figure out what you're going to round it to. Now, typically in IB, what they do is they round to 3 significant figures, but we'll get into that later. So, we're going with a round off now. Now, rounding off with decimals. So we're going to round this off to 1 decimal place. Now, 1 decimal place is the 10th place. So we're going to round this off just as we did before. What do you think this rounds to? Well, since we're rounding to 1 decimal place, we're rounding to the 4. So we have to use the number right after it, which is 3. 3 is less than 5. So that means our answer is going to be round down, and your answer is 8.4. And that's it, and you're done. Right? Problem B, go. All right. 2 decimal places, 1, 2, so we're going to use these 6. 6 is greater than or equal to 5, correct? Round up. So your answer is 3.52. And you're done. All right. Oh, dropped it. There you go. Let's do some extra exercises. We're taking this up a level, see? What we're doing here is called tiered learning or something else learning, where you just start slow, we build upon it, build upon it, build upon it, and pretty much you're at the end, and you don't even realize how much you built up. Isn't that nice? The tiger's moving up on me. All right. In the bread brackets, that tells you how many decimal places you're going to. These are the numbers you're rounding. So, you should have got the first one. Let's just check to make sure you're right. 6.181, 6 and 181 thousandths, right? You're rounding to the 10th place because you're going 1, so you're using the 100th place, which is 8. 8 is greater than or equal to 5, obviously. So your answer is going to be 6.2. 2 decimals, you're rounding to the hundredths. So you're using the 1000th place, 1 is less than 5. 6 and 18 hundredths. 3.25. You're going 1 place. You're going to the 10th. All right? So you're using the 100th place. 5 is greater than or equal to 5. All right? You round up, 3.3. 17.403. What you're doing here, 2 decimal places, you're rounding to the 100th place. So you're using the 1000th place. 3 is less than 5, 4.40, 4 and 40 hundredths. All right. 3, you're rounding to the 1000th place, so you're using the 10,000th place. 5 is greater than or equal to 5. The 1 turns into a 2. 2 and 132 thousandths. How am I doing so far? I didn't make any errors, did I? Please. You gotta email me if I made a mistake. I won't get mad. I'm happy to fix this. F. 1 decimal place. So we use the hundredths. 9 is greater than or equal to 5. 0.2. 2 decimal places. Use that 7. 7 is greater than 5. Now, 9 rounds up, so instead of a 0, 9, it becomes 1, 0. You leave the 0 here, okay? Because we're rounding to this place, so you have to leave your 10th place there, 100th place. So it's 10 hundredths. Even though I know you can just drop the 0 typically, but to show it's more accurate, you would leave that 0 there. Rounding the 2 down, so you get 102 and 38 hundredths. All right, hopefully you got all those. If you didn't, practice, practice, practice. All right, do 2 through 5. You guys remember who Usain Bolt was? I think he almost beat a cheetah. All right, you ran the 100-meter dash in 9.58 seconds. And he used to run and beat people by so much he would pull up like 10 meters short and still like set world records. All right, so Usain Bolt ran 100 meters in 9.58 seconds. Round this time to 1 decimal place. So 1 decimal place would be 5. So we're using the 8 to round. 8 is greater than or equal to 5, right? So the 5 rounds up. And we get 9.6 seconds. Average height of children in a class is 1.435 meters. Now you'll notice a lot of the units we use in IB are meters and are the metric system. That's because this book is used throughout the world And America happens to be, unfortunately, the only country to use standard measurements, like inches, feet, miles, which isn't very good. And if you become an engineer one day, you'll realize you'll never use that stuff again. Everyone uses the metric system because it's a lot better, because it's all by units of 10. So, that's a little fun fact right there for you. Average height of children in a class is 1.435 meters. Round this to 2 decimal places. Move 5. 5 is greater than 5, right? So since 5 is greater than 5, what do you do? 1.44 meters. All right. That wasn't too terrible, was it? Next one, the thickness of a sheet of paper is 0.12 centimeters. Round this thickness to 2 decimal places. All right. What do you think? Rounding it to the 10th place. So we can use the 2, that's less than 5. Your answer is 0.01 centimeters. All right, sound good? Awesome. The number pi is a mathematical constant. The first 6 digits of pi are 3.14, 159. I want you to round it to 1 place, decimal place, 3 decimal places, and 4 decimal places. All right, let's see what we got here. 1 decimal place would be to the 10th place. So we're going to use the 4. 4 is obviously less than 5, so your answer is 3.1. Right? 3 1/10. 3 decimal places. So we're going to round it to the 1,000. We're going to use the 5 as our rounding tool, you can call it. 5 is greater than or equal to 5, so the 1 rounds up to a 2. 3.142 is your answer. 3 and 142 thousandths. 4 decimal places, we're going to round to the 10,000, so we're going to use the 100 thousandths. This 9 is greater than or equal to 5, so the 5 rounds up to a 6, and you're left with 3.1416. Same answer, rounded 3 different ways, depending on what decimal place you want to round to. Alright? Alright, good. We're about halfway done. So we're making some good time here. But let's keep going. Alright, so the fraction 5 over 16, 5/16 is, what's that word? Approximately. 0.2631578995. Round this number to these things. So number 1, 1 decimal place. Round to the tenths. We're going to use the 6. 6 is greater than or equal to 5. 3/10 is your answer. Rounded to 2 decimal places. And you should have paused me and finished these problems already. Don't just copy down what I'm saying. Try them first. Try them first. If you mess up, guess what? Erase your answer and fix it. It's fine. But then you know what your mistake is and you fix it. Learn from your mistakes. Mistakes aren't bad, especially when you fix them. Unless they're really bad mistakes. All right, so 0.263. 300ths. We're going to use that. That is less than 5, so we're going to just leave our answer as 26 hundredths. Got it? 6 decimal places. So we're going to use the 7th decimal place as our approximation tool, whatever you want to call it. Greater than 5, so the 7 rounds up to an 8. And our answer is 0.26315. There you go. Now, hopefully you guys are using a calculator. If you don't have a calculator at home, you should have a calculator right on your IB book website. All right, so first thing you do is you type square root of 2 into your calculator, and then we're going to round it to 3 decimal places. So when you type in your calculator, you get 0.4142. So I only wrote the 4 decimal places because that 4th decimal place is the one that we're going to use to round it. We're going to use that number, less than 5, to round that 4 down. So our answer is approximately 1.414. All right? Square root of 5. In your calculator, 2.2360. You can keep on going if you want, but since we're rounding to 3, we only care about going to 4. 0 is definitely less than 5. So our answer is 2 and 236 thousandths. 23. Type in your calculator. 2nd x squared, 23. Enter. 4.7956. 4.58. 8 is obviously greater than or equal to 5. So this 5 right here rounds to a 6, and you get 4.796 as an answer. Right? Cubed root of 4, not square root, so you're going to type in a 3. I believe it's the second button, but it's the one that has like a little, it's the symbol with like, I don't know, these Sharpies. It's like a little X, and then it has the square root symbol, and then you type in your 4. The X would be wherever that 3 is in the symbol. So you type that in, you should get 1.5874 as an answer. 4, less than 5, 7 stays, 1/587,000. Here, oh, can you take the cubed root of a negative? You actually can. You can take an odd root of a negative number. If this was square root of negative 15, you would get error on your calculator. The reason for that is you can't take a square root or any even root, that is, of a negative number. It's undefined. You can't do that. But because this is an odd number, you can. And your answer would be negative 2.4662, blah, blah, blah. The 2 is less than 5, so you round down. Negative 2 and 466 thousandths. 76630, blah, blah, blah. The 0 is less than 5. Your answer is 7.663, approximately. Right? There you go. You doing good? Hopefully. You're going, oh, maybe IB is not going to be too bad. Get some friends in here. Have them come. Uh-oh. All right. This really isn't taking it up a level, but this is just adding something to it. So we're going to calculate the following answers to 2 decimal places, but you can do a little math first. Now, I do understand that you can type this word for word in a calculator and solve it, but I like to write this out in steps. That makes me remember my regular arithmetic a little bit better, and that's just me personally. So, in order to do a problem like this, you have to remember something. And I know you guys all remember this, but I'm going to put it up here anyway. It's called Pandas, all right? What's it? Please excuse my dear Aunt Sally. This is used all the time. I always write this, I teach calculus. I always write this on the board in calculus class, because sometimes students just forget. The P is the first thing. So anytime you see a P, you do that first. That would be parentheses. So anything that's in parentheses, you solve first. The E stands for, yelled out, exponents. So anything raised to a power, you solve second, unless that thing is in, M and D. These are kind of interchangeable, okay? Multiply and divide. Okay, so you're either going to multiply or divide. It doesn't matter what order you do them in. You can kind of interchange them. They always just say you multiply before you divide. Dividing is just multiplying by reciprocal, so technically it's the same thing. And then last, the AS is addition or subtraction. Okay, once again, adding a negative number or just subtracting a number, same thing. So you can kind of mix them up. So parentheses, exponents, multiplication or division, and then add or subtract. So in this case, there's an A that goes last, but it's in parentheses, so you do the parentheses first. Add those two numbers together, you get 29.2, and then you're going to multiply it by 17.1, and you get an answer of 499.32. Now what I did was I rounded this to 2 decimal places, and it actually came out to perfect like that. Next one. What do you think you do first here? Multiply comes before addition. So 16.8 plus 212.04. Add these together and watch what happens. You get an answer, and you don't need to round it because it only goes to 2 decimal points already. So it's 228.84. If your answer only goes to 2 decimal places, all right, you don't have to round it. You just put what your answer is. Division before subtraction. So 127 divided by 9 is 14.1 repeating. 1/9 is 1, 1, 1, 1, 1, 1, 1 forever. Okay, minus 5. This becomes 9.11. We only have to go right to 3 decimals because we're rounding to the 2. And this is less than 5, so it rounds down. Our answer is 9.11, or 9 and 11 tenths. Hundreds. All right. What do you do first? Parentheses. 9 minus 5 is 4. 127 divided by 4 is 31.75. No need to round it. Here. All right. First step, parentheses. 4.2 minus 2.7 is 1.5. Second one, no exponents up, multiply or divide, we have division. 37.4 minus, okay, we don't have to do that, 16.1 divided by 1.5. We do this first. 37.4 minus 10.733. Subtract the 2 and you get 26.667, so pretty much 26 2/3. 7 is greater than 5, so it rounds up. So this 6 right here rounds to a 7, 26.67. When you do division, you're going to divide on the bottom first, add these together. 16.84 divided by 19.1. All right, so you always do fraction bar, top numerator, denominator first. 0.881, 1 is less than 5, so your answer is 88 hundredths. Right? Getting in the groove yet? All right, 27.4 divided by 3.2, 18.6. So you have to do divisions before you do the subtraction. So you divide this, you get about 8.5625. This you get about 1.1552. Subtract the 2. I'm just going to cut off the 3 on the end. 7.407, greater than 5, so we round this up. 7.41. Remember, we're only going to 2 decimal places. Here, top of the fraction bar first, because this is kind of like parentheses up here. 10.6 divided by 8.6. Now you do your division. 1.2325. Now you do your addition. 5.932. 2 is less than 5. 5 and 93 hundredths. Okay. All right, you're going to add these together. Your arithmetic getting a little stronger. Should be. 7.1768 divided by 114.866. Divide the 2, you get 0.482 and some more stuff. We only care about the third one. That is less than 5, so we're going to round this 8 down, keep it to an 8, and you get 48 hundredths. Right, that was a pretty easy problem, wasn't it? Wasn't too bad. Almost to the end of this chapter. Ready for another? Boom. Over a 23-game water polo season. So, try these problems, obviously, pause it, play it. 23-game water polo season. Carrie scored 40 goals for her team. Carrie's average number of goals per game. Find it. Two decimal places. So how do you find goals per game? So, 23-game season. She scored 40 goals. Goals per game. So goals is on top. Per is your fraction bar. Games on bottom. So how many goals did she score? Goals per game. Scored 40 goals. 23 games. 40 divided by 23. 1.739 blah blah blah. We're only going to 2 decimal places, so we only care about the third. Greater than 5. So you round it up. 1.74. Average goals per game. Carrie's pretty good. I think that's pretty impressive. Look at that. Water polo, in case you don't know, is when you're swimming in a pool and you have a ball and you throw it in a goal in the pool. So it's kind of like soccer, but you use your hands instead of your feet, and you swim instead of run. It's an interesting Olympic sport. All right, oops, sorry, next one. Wang used a measure, a tape measure, ruler, to check the length of his kitchen bench. After viewing the tape, he recorded the length to be 2.54, 2 and 4500 meters, which he rounded to 2.5 meters. So he did a little rounding. When his mother asked him about the length, he said, it was about 3 meters. Why? Explain why what he did was wrong, and discuss why you need to be careful when we make approximations. Now, we're going to discuss this one actually in class. All right, so, but I want you guys to think. Why is what he did wrong? Okay, did you write down what you think? Did you say what you think? The reason is you cannot round the same number twice. You don't want to round this up to 2.5 and then round it to 3. Because if I was going to round this to 3 meters, okay, it would be, I would use the 4. And 4 is less than 5, I would have to round down to 2. Okay? Because 2.45, if I round this to the 10th place, it's 2.5. Okay, good job, Wayne. 2.5. Just stop right there. But if I round 2.4, I'd have to use this 4 right here. That's about 2. So it would never be approximately 3. Right? That makes sense? Yes, no, maybe? Maybe I'll give you a couple more in class. All right. We're going to have a discussion like this in class too, but I'm just going to discuss this with you. Square root of 61 is approximately 7.810224. ... Mateo rounded his number to 2 decimal places, giving an answer of square root of 61 is about 7.81. Hiba rounded this number to 3 decimal places, giving you about 7.810. Okay. Would it be fair to say Hiba's estimate is more accurate, even though they're the exact same value? So, before we discuss, I want you guys to think about it, because IB is not just about solving problems. It's about thinking and using knowledge. Now, virtually, it's not the best way to do this, because it's harder to do class breakouts, but you can still think of it on your own. What do you think? Are these the same exact answer, or is Hiba's answer more accurate? So I want you to yell right now. Yes or no? Is Hiba's answer more accurate? And I can hear you. You didn't yell. Do it again. A little louder. All right. I'm going to see if you're right. Yes, it is more accurate. Why? Now, if you said no, think. Don't just read the answer. Think. Why? Got it? You got to think? The reason this is more accurate is this 0 represents I'm going to the 10th, 100th, 1000th place. This is only rounded to the 100th place. So this is going to be a 0, okay? And this number over here, this could be like a 4, could be like a 3, could be like a 2, could be a 1. This, the highest number this can be pretty much is a 0. Because this is either going to be 0, 1, 0, 2, 0, 3, 0, 4, or it's going to be 0, 9, 5, 0, 9, 6, 0, 9, 7, 0, 9, 8, 0, 9, 9. So you'll never be able to get this number to be a 2. This one could be a little bit higher. It can be 8.1. This can even be a 4. Nope, sorry. This number right here can even be like a 4. Be a 3. Got it? Make sense? Hopefully. Rounding off the significant figures. The first, now this is how we're going to end class. All right, what do we got? We got about 9 slides, 8 slides left. So this is pretty much the third section of this lesson. This is where we're going to bring everything we have together and just give you a little bit more, okay? Like I said, it's like tiered, like little chunks. You get chunks of harder and harder. So significant figures, this is the important stuff. What you need to know is the first significant figure of a decimal is the first, which is the leftmost non-zero number, okay? Digit. So the first significant digit of 4,567 is, remember when I point you out your answer, 4, because it's the first number all the way to the left. So it's the largest non-zero number. The first significant figure of 0.01234 is, and the leftmost number here is 0, so what do you think it is? It's 1, because it's the first, here's the key, non-zero digit. Okay, so leftmost non-zero. Okay, every digit, all right, to the right of the first significant figure is regarded as another significant figure. So this one has 1, 2, 3, 4. This one has, you have your first one, 2, 3, 4. Now, even if you have a 0 to the right of it, that counts as a significant figure as long as your leftmost digit is a non-zero. In the IB exams that you guys are taking next year, you are expected to give all your answers to 3 significant figures unless otherwise specified. So in this class, a lot of the times we'll just be going to 3 significant figures. Now, sometimes that's to a whole number, sometimes that's to 1,000, sometimes that's to a 10th. So what decimal place we're going to a lot of times doesn't matter. It just matters that you have 3 significant figures there. All right, so here's how you round to a sig fig. To round off to these numbers of significant figures, first thing you do is you count the specific number of specific figures, and then you look to the next digit. So, if the digit is less than 5, that's step 1. Step 2, what do? Less than 5, you round down. 0, 1, 2, 3, 4. Look familiar? It should. We just did this. If the digit is 5 or more, you round up. 5, 6, 7, 8, 4, 9. So the same rules apply with regular rounding with significant figures. The only difference is you're rounding to different places. You're not going to say round to the 6th place. You'll say round to the 3rd significant digit or 6th significant figure. Okay. You delete all the figures following the significant figures, replacing them with zeros when necessary. All right. Got it? Example 3. This, a little better explanation in the book, but I'll explain it in words. Round it to 2 significant figures. So number 1, I have to round it to the second 3, 9, 0, so 1, 2. So what number am I going to use to round this? The 6. 4 is the second number after 3. That is the first number after 3, but it's the second number. Okay? And then we're going to use our 6 to round. 6 is greater than or equal to 5, so we're going to round this 4 up. So our answer is 3.5. That's it. All right? Look at problem B. All right, so what I want you guys to do here is establish what is your first significant figure. That's the important part. What's the first one? You should have said what? What should you have said? When you're rounding to 2, 7 is my first significant figure. See these zeros before? Because they're not numbers that are non-zero, these do not count. So you start with the 7. So that's number 1. Your second significant figure is 2. The zeros do not count. We're going to use our 4 as our rounding tool. 4 is less than 5, so you round down. So our answer is 0.0072. That's it. All right? This one, rounded to 1 significant figure. So what's our first significant figure here? The 7, the leftmost non-zero number. Now, we're going to use our 0 to round it. 0 is less than 5, so you round down. And our answer is 700. All right? This one, 3 significant figures. Now, this is our first one. The third number is 1. Now, you don't say first significant figure, second, third, and skip the 0. Because the 0 comes after our actual number, okay, what you do is that counts as a significant figure. So 1, 2, 3. Okay? As soon as you have a real number, anything after that, including zeros, is significant figures. So 1 is the third number after 2. We're going to use our 5. 5 is greater than or equal to 5, so we're going to round up. So our answer is going to be 20.2 or 20 and 2 tenths. All right. You ready to do some on your own? You got those? You know all the tips and tricks now? So you're going to do same thing we did before, but now we're doing with significant figures. You see these exercises are very similar, just slightly different. You're going up in difficulty every time. Let's go. First one, 128. Ready? 2. So 1, 2. We're going to use the 2. We're going to round to the 10th place. 8 is greater than 5, so our answer is 120, 130. It is 130. All right? 2. So we're going to round 2. Now the 100th place. So we're going to use the 10th place. All right? 4 is less than 5. 8,300 or 8,400? 8,300. Very good. C. Now our second significant figure place is the 10th place. So we're going to use the 100. 6 is greater than or equal to 5. 5 rounds up to a 6, and you get 2.6 as an answer. Notice in each case, we're rounding to 2 significant figures, but the answers are vastly different because we don't care really about the places. We care about the significant figures. In this one, first significant figure is 1, so we're rounding to the 100th place, so we're going to use the 4. 4 is less than 5. 3 stays the same, so your answer is 13 thousandths. All right. Boom. 1, 2, so we're going to go to the 10 thousandths. 3 is less than 5, so 160,000. Here, watch what our significant figure is. Our second one's actually the 0. So we're going to use the 100th place to round. It's greater than or equal to 5. Yes, our answer is 1 and 1/10. 100 is what we're rounding to. That's 1, 2. So we're going to use the 5, which is greater than or equal to 5. 39 plus 1 is 40, so our answer is 4,000. 6.611. We're going to round to the 10th place, so the 100th is a 1. Less than 5, our answer is 6 and 6/10. Right? Good? All right, let's move on. Round to 3 significant figures. Almost there, almost there, almost there. Check, make sure my video is still coming. Ooh, it's about an hour. All right, 83,000. So 1, 2, 3. So we're going to round to this place right here. So you look at the 6. 6 is greater than or equal to 5. So that means when I pick up my ruler, we're going to round the 0 up to a 1. 83,100. First, second, third. So we're going to round the 100 up again. So we're going to use this 4. Less than 5. 10,000. Doesn't count as a significant figure. First one, second one, third one. So we're going to round to the 1,000th place. 2 is less than 5, so the 5 stays the same. 105 thousandths. Here, 3, 1, 2. We're going to round to the 10th place. Use the 100th place, which is greater than or equal to 5. 6 rounds up to a 7. 31 points. 1, 2, 10th place. This is a 0. 0 is obviously less than 5. So our answer is 70 and 7/10. F, 1, 2. We're going to round to this place. Even though these are zeros, first one, second one, third one, fourth one, fifth one. Round to the 3rd, which is the 100th place. The 1,000th place is a 0, so it stays at 4.00. You don't drop the zeros. Okay, you would just say 4 and 0 hundredths. Right? More accurate than just putting 4. This one doesn't count as 1. This is 1, this is 2, this is 3. So we're using that 1 as a rounding tool. I don't even think it's called a rounding tool. I just can't think of anything else better to call it. 7 stays the same because you're rounding down. And you got 367 10,000ths, or 0.0367. Rounding to the 10th. So we're using the 100. 8's bigger than 5, so this 1, 9, this becomes a 0. This becomes a 0, so 199 plus 1 is what? 200, so your answer is just going to be 20.0. Right? And you keep on going 9s, you just keep on carrying your 1 over. It's like addition. Right? How are we doing so far, right? What number is this? 2? Ready for 4? All right, I think we only got 10, and then we're good, and then we're done. All right, round 4 significant figures. So 1, 2, 3, 4. You're going to round to the 100th place. Use the 2. 2 is less than 5. 16.38. Right, I'm going to go a little bit quicker now because I assume that you guys are doing all these. 4, 1, 2, 3, 4. You're going to round to the 10th place. You can use the 0. Less than 5. 438 and 2/10. 1, 2, 3, 4. You're going to round to the thousands place. You're going to use that 6, which is greater than 5. So the 3 rounds up to a 4. 6,874,000. Right? 4, these zeros don't count. Use the leftmost non-zero digit. So 1, 2, 3, 4. We're going to round to this place right here, which is the 10, 100,000, 100,000ths. Use that 5. That 5 is greater than or equal to 5. Answer is 0.2889. Because this 8 right here, the third 8, rounds up to a 9. Right? All right, problem number 4. The exact crown size at a rock concert. Crown? There's a mistake. The exact crowd size. Why would there be a crown at a rock concert? You guys ever hear that? All right, so we're going to go, this is C. Exact crowd size at the rock concert was 96,257 people. One significant figure rounded to. So which one are we going to use? That's So we're going to use our 6. 6 is greater than 5. Round the 9 up to a 10, so it's a 100,000. 2 significant figures, so we're going to round it to the thousand place, so we're going to use the 2. 2 is less than 5. The answer is 96,000. Notice a little bit of difference here. 3 significant figures, so we're going to round to the 100. We're going to use that 5. 5 is greater than or equal to 5, so the 2 rounds up to a 3. 96,300. So these two answers are similar. This one's a little bit off. They didn't round good enough. So what you would need to do is pretty much round it to probably 2 significant figures at least. But like I said in IB, everything's 3. All right, back to these fun problems. Evaluate the following. Give your answers to 3 significant figures. Now it's not decimals, it's figures. Second, x squared 7. Square root of 7. 2.645. I'm just going to stop at the 4 significant figure for each of these to show you how I'm rounding. This is greater than or equal to 5, so our answer is 2.65. Okay. 2 pi, so this is 2 pi times 3.14, blah, 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 blah. So you get 2.6283. 3 is less than 5. 8 stays, 2 and 6 and 28 hundredths. 36 divided by 17. 2.117. 7 is greater than or equal to 5. About 2 and 12 tenths. Notice they're all to the 10th place so far. Not anymore. All right, so 517 times 3,802. 1,965,634. We're only going to 3 figures, 1, 2, 3, so we're going to use the 4th significant figure, which is 5. Greater than or equal to 5, so we're going to round the 6 up to a 7, 1.97 million. All right. 0.96986 to the 5th power. So that's the caret button, 5, and you should get 0.9319. Blah, 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 blah. 9 is greater than or equal to 5. 2 rounds up to a 5, 932 thousandths. F, do your numerator first. Subtract the 2. You get, I don't know, 13 point something divided by 3.1. You get 4.393 is an answer. 3 is less than or equal to 5. 4 and 39 hundredths. 5.5 minus 2.18, and then you do the square root of that answer. So it's the square root of 3.22, 1.794. The 4 is less than 5, so 1 and 79 hundredths. Whew. 9.58 divided by, in parentheses you would put second x squared 2.8, square root of 2.8. And you get 5.725. The 5 is greater than or equal to 5. So the 2 rounds up to a 3, and you get 5 and 73 hundredths. Right? Not too terrible, right? Ready for the last of the difficult problems? Word problems. You guys love word problems, don't you? All right, we're almost done. A theater has 32 rows with 28 seats in each row. Find the total number of seats, rounding your answer to 2 significant figures. So, 32 rows, 28 seats in each row. How do you find the total number of rows? Seats times rows. 32 times 28. That equals 896. We only want to go to 2 significant figures. So we're going to use the 6 right here, and we're going to round 896 up to 900, because 89 plus 1 is 90. All right? Good? Next one. Ballroom has dimensions of 30.1 meters by 8.5 meters. So that means it's 30.1 meters wide and 8.5 meters width and long. All right, so find its area. How do you find area? Length times width. Multiply the 2 together. 30.1 times 8.5 equals 255.85. Since we're going to 3 significant figures, 1, 2, 3, the Fourth one is greater than 5, so we're going to round up the third one. 5 goes to a 6, and you get 256 square meters. All right? This is 900 feet. I should have put the units. I didn't. Sorry. All right. The proceeds at a garage sale were $752. All right? And 25 cents. And this was shared equally between 4 people. Calculate the amount each person received. So, you're going to take that number and you divide it by 4. When you do that, you get 188.0605. Now, when you round it to 3 significant figures, 1, 2, 3, you're rounding it to the dollar place. You're going to use the 0, less than 5, so it's $188.00. Why do you put the 0 cents in the end? Just because it's money and you want to put cents in the end. And the 5 significant figures. 1, 2, 3, 4, 5. So you're going to end up in the penny place. So you can use the number after the penny, which is also a 0, less than 5, so we keep the 6, $188.06. That's it. Good? Any questions yet? If you have questions, email me. Ask me in the Zoom, WebEx meeting. Speed of sound in dry air. Dry air is just air that has no humidity. At 20 degrees Celsius is 243 meters per second. Calculate how many meters, and Ivy Book spells meters different. It's just how it's spelled overseas. Sound travels in 1 hour, giving your answer to 2 significant figures. So, if it's 343 meters per second, how do we find that to hours? So how many seconds are in an hour? Let's see. You know that there is 60 seconds in a minute. Those of you that had me in geometry should remember this. And there's 60 minutes in an hour. Now the way you want to set this up is, this is 343 meters per second. So we have the seconds in the denominator. So when we use our conversion, seconds to minutes, you want your seconds in your numerator, because the word second will actually cancel out. Now I have minutes in denominator. So now I want minutes in numerator, so I use minutes per hour. So the word minute cancels out. So all I'm left with is the units of meters over hours. And then I multiply the numbers across. 343 times 60 times 60. 1 times 1, 1. And this times this times this is 1,234,800. I want to go to 2 significant figures, so I want to go to the 100,000 place. 3 is less than 5, 1.2 million. All right, and that is meters per hour. All right. Whew, almost there. How are you feeling? You like this so far? You're almost done with 1 unit of 1 chapter of this. Oh, let's finish it off with a fun one. Why don't you guys read that real quick? It says to calculate the area of the circle, Eric performed the following calculations. The diameter of a circle, use Pythagorean theorem. A squared plus b squared is 6 squared. So we said, okay, so that means the square root of 6 squared plus 6 squared is square root of 36 plus 36. Square root of 72 is about 8.49 centimeters, using his IB 3.3 significant figures. Okay, I'm going to find the radius now. So I take this diameter, divide it by 2, and I get about 4.25. All right, now the reason you got 4.25, you really got 4.245, but then he rounded the 4 or 5 up to 5 using his 3 significant figures. Area of a circle, pi times radius squared, and you got 56.7 square centimeters. Final answer. He rounded to 56.3 square centimeters. Can you explain why that possibly may not be his final answer? So think about it. Think. All right. Now, the reason for that is you get the most accurate answer by rounding only once. So what that means is, instead of doing this problem, rounding it, and this is what we did in the beginning, do this problem again, rounding it, and then doing this problem a third time and rounding it, what you do is you're going to make this one giant problem with no rounding until you get to the end. So what you do is, you go, okay, I know the area of a circle is pi r squared. So it's pi times, okay, my radius is 1/2 of this answer, right? So it's 1/2, well, the diameter is square root 72. So I'm just going to leave the square root of 72 because that's exact. So pi times 1/2 square root 72. That's as accurate as you can get for the radius, squared. Okay, so I do 1/2 times square root of 72, all right, squared. That's 18. Comes out 18 even, squared. Okay, how do I know that? Because 72 is technically square root of 36 times square root of 2, right? Square root of 36 is 6. 6 times 1/2 is 3. So this inside is 3 square root 2. 3 squared is 9, square root 2 squared is 2, and 9 times 2 is 18. So I can do that in head, you can do it with a calculator. So pi times 18 is 56.5486. Now we're going to 3 significant figures. So we're going to this place right here. So we're going to use this 4 to round. The 4 is less than 5, so we're going to do 56.5 as our answer. A little different. All right? This is almost exact with 3 figures. This, because what happens is you took a little bit away here, took a little bit more away here, and by the time you got here, you took, you added some, and by adding things and taking things away, actually you added a little bit here, took a little bit away here, added some here, all that little manipulating inside takes away some of your problem. It won't be off by a bunch, but it'll be off by enough that if you are trying to calculate things pretty accurately, it's no good, right? And that's because I used the 4. All right? And the 4 was less than 5. Got it? Guess what? This completes our first chapter, 1.A, rounding numbers. Okay? So, as of now, based on what I just taught you, and what you already know, you should know how to round off whole numbers. You should be able to round off decimal numbers, and you should be able to round significant figures. Okay, so I just gave you 3 great tools that by themselves aren't really useful, but they will be used throughout this year in order to solve better problems, okay? And then we'll discuss a lot of this stuff too in class and see how it goes, but hopefully you understood all this. Hopefully the way I taught this was okay with you and you enjoyed it. And until I see you next time, goodbye.